Section 12.4, the cross product. So in our previous section, the dot product, we had one definition of how to multiply two vectors together, the dot product. This is going to be a different way to multiply two vectors together. So some learning goals here. So we'll do our definition in terms of determinants. That's how we'll define the cross product. So you should be able to compute 2 by 2 and 3 by 3 determinants. You should know the definition of the cross product, and then there's a lot of properties of the cross product. And then we'll be talking about connection of the cross product to areas and volumes in geometry. We'll be talking about the geometric significance of the cross product in many different ways. Okay, so we won't define the cross product in this video. We'll define determinants, and then next video we'll be using determinants to define the cross product. So determinants of matrices, I'm just going to talk about 2 by 2 and 3 by 3 determinants. You can definitely define determinants for larger square matrices. You want to take our Math 250 Introductory Linear Algebra course, you can learn a lot more about determinants in that course. We'll just be limited to 2 by 2 and 3 by 3 determinants. Okay, so definition for the determinant of, I'll start off with 2 by 2 matrix. So we have a matrix numbers A, B, C, D here. The determinant of this matrix, and sometimes I will just put absolute value bars around it to represent the determinant here, is all you have to do is the upper left times the lower right minus the upper right times the lower left. So this is A times D minus B times C. This times this minus this times this. So for example, the determinant of 1, 2, 3, 4 would be 1 times 4 minus 2 times 3. So 2 by 2 determinants, pretty simple thing to define. So the next up is going to be 3 by 3 determinants, and this is the important case for us. We'll be defining the cross product in terms of a 3 by 3 determinant. Okay, so what you do is that we're going to reduce down this 3 by 3 determinant down to a sum and difference of 3 separate 2 by 2 determinants. This is how we do it. We're going to expand along the top row. So we're going to take, this is going to equal, so the first entry is going to be take the upper left entry, this 4, and then cover up the corresponding row and column. So I just covered up the top row, the first row, and the first column. I see 4 numbers in the 2 by 2 matrix left over here. Multiply 4 times the determinant of this matrix down here. 3 minus 7 minus 5 and 1. And then the second term that we'll have is going to be take this second entry here, the 6, and we need to slap a negative sign on the 6. But again, we're going to cross out the row and the column corresponding to the 6. So let me cross out using my markers right there. And so now you can just see 1, minus 1, minus 7, 8, 1. So multiply negative 6 times the determinant of this new matrix. And then one last time, we're going to take the final entry in the top row, this 2 here. And so it's going to be plus 2. So the signs go plus 4 minus 6 plus 2. This middle entry comes with a minus sign. Cross out the row and column corresponding to that. We see 4 entries left there. Take the determinant, the 2 by 2 determinant right there. Okay, so this is how we're going to find the 3 by 3 determinant in terms of 2 by 2 determinants. And let me just point out here how to compute these. So this is going to be 3 times 1 minus -5 times -7, minus 6 times -1 times 1, minus -7 times 8, plus 2 times -1 times -5, minus 3 times 8. So I'm not going to bother to do the arithmetic here to give you what that is, but this is how we compute a 3 by 3 determinant. Let me show you one other trick, another way to think of 3 by 3 determinants. It gets you to the same answer. And I learned this trick back when I was in high school, so let me show off to you. It involves you recopy the first two, so those are the same matrix as we had before, same by 3 by 3 matrix. We recopy the first two columns of the matrix to the right for -1, 8, 6, 3, -5. And this is how we do it. This is how we compute it. We're going to take diagonals. We're going to take this diagonal here and multiply those numbers together. So our answer is going to be 4 times 3 times 1. We're going to take this diagonal 6 times, so plus 6 times -7 times 8. We're going to take this third diagonal here, so plus 2 times -1 times -5. So these are all three possible diagonals moving from the upper left to the bottom right, going this way here with 3 entries in them. Now we also have to go from the bottom left to the top right. So we have to multiply together 8, 3, and 2. And for all of these ones going from the bottom left to the top right, we're going to slap negative signs on them. So minus 8 times 3 times 2. And then minus -5 times -7 times 4, minus 1 times -1 times 6. So this is another way to get to the determinant. Both of these ways are legitimate ways to compute them. And I should say, I don't want to be too restrictive on this. If you've learned other ways to compute 3 by 3 determinants previously in your math career, you're certainly welcome to use them. I present here 2 ways to compute determinants. Okay, so that's an introduction to determinants. Next video, we'll be seeing how to define the cross product in terms of 3 by 3 determinants.